This is a continuation of pre-calculus 4.5 homework. Continuing on, we're on problem number 53. This one, you have a radical in the denominator of this fraction. So you're going to get rid of this negative root 2 and write it as root 2i. So now, what is the conjugate? The conjugate would be 1 minus root 2i. So 1 times this is going to obviously be 1 minus root 2i. And then in the bottom, 1 times 1 is 1. The next 2 will cancel out. And then root 2i times negative root 2i is going to be negative 2i squared. Or really plus 2. So this is really plus 2. Simplify it, you get 3. So it's 1/3 minus root 2 over 3i. That's in your a plus bi format. Okay, the back side. These ones are solving quadratics. So what you're going to have to do is use the quadratic formula because they're not factorable. Unfortunately, they're not factorable. So what you're going to do is revisit the quadratic formula on these, 59 through 65. So this says 3x squared minus 2x plus 5. You need the a. It's not factorable. Kind of looks like it could be. A is 3, and it's in standard form. B is negative 2, and C is 5. So the quadratic formula states that it's the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So if B is negative 2, you've got the opposite of that, which is 2, plus or minus negative 2 squared is 4, minus 4 times 3 times 5. All over 2 times 3, which is 6. So what we have here is going to be a negative. This is going to be 15 times 4 is 60. So it's 4 minus 60 all over 6. And we're going to keep going. 4 minus 60 is negative 56. And I'm writing every step out. Root 56i. Now 56, root 56, can be broken into 2 times 28, and then 2 times 14. So we have a pair of 2's that come out. So it's 2 plus or minus 2 root 14i over 6. Now you could pull a 2 out of these. So you're left with 1 plus or minus 1 root 14i over 3. So if you cancel these 2's, put 1's in place, and this is a 3, you have 1 plus or minus root 14i over 3. Now you could break this up as 1/3 plus or minus root 14 over 3i. And that's in standard form. The next one, the quadratic formula, it's in standard form. It's the opposite of B. B is 1. So negative 1 plus or minus the square root 1 squared minus 4 times 1 times 2. All over 2 times 1, which is 2. So this is negative 1 plus or minus This is 8, 1 minus 8 is negative 7. So let's get rid of this negative. And you can break this up into negative 1/2 plus or minus root 7 over 2i. And that's in standard form. 63. This one is in the wrong order. It's not in standard form. So you're going to write 2x squared minus x plus 4. So the quadratic formula says the opposite of b, which is 1, plus or minus 1 minus 4 times 2 times 4, all over 2 times 2, which is 4. So this goes to 32, so 1 minus 32 is 31, but it's negative because it's 1 minus 32. So your answer, getting rid of this negative 1, is 1 plus or minus root 31i all over 4. And you can break this up into two parts, 1/4 plus or minus root 31 over 4i. And the last one, 65. Your quadratic formula will be used on this, but your a, b, and c are in the wrong order, so let's write it in standard form. 2x squared, this is your b value, but it's minus 6x plus 3. So your quadratic formula says it's the opposite of b, so negative 6 is b, so it's 6 plus or minus b squared, so 36 minus 4 times a times c, all over 2 times a, so 2 times 2 is 4. So let's clean this up. We have 36 minus 8 times 3 is 24. So this one, this is going to go to 12. This is not a negative. So we don't have the I in this one. So these are two real solutions. Root 12 is really 2 root 3. And you can simplify these all, divide 2 into all these. So this is going to be 3, that's going to be a 1, and that's going to be a 2. So the answer 3 plus or minus root 3 over 2 is a good answer. Or you could write 3/2, that's your a value, and your b value, well, this is not a complex number, so it's 3/2 plus or minus root 3 over 2. You don't have an I here, because that's not a negative, it's not an imaginary number. And the last two. How do you factor x cubed minus 8? You want to find all three solutions for this one. So this, you're going to have a binomial and a trinomial. So x minus 2, remember this is x times x times x, and this is 2 times 2 times 2. So you take one of each of these, x minus 2, and then these two multiply together, switch the sign, multiply these two, so you have 2x. This sign's always a positive, and 2 times 2 is 4. So one of your solutions is you're going to set x minus 2 equal to 0, so x is 2. That's one answer. These two, you're going to have to use the quadratic formula. So x is equal to the opposite of b plus or minus b squared minus 4 times a times c, all over 2 times a. So this is going to be 4 minus 16, which is negative 12. Simplify that. So this is gonna be, 2 root 3I. And then 2 goes into 2 and 2 here. So this is gonna be -1 plus or minus root 3I. So your answers are 2 and -1 plus or minus root 3I. Because these 2's canceled out. And the last one, there are 4 zeros here. This is the difference of 2 perfect squares. X squared minus 1 times x squared plus 1. Set each of these equal to 0. Square root both sides. So it's plus or minus 1. And then on this side, x squared plus 1 equals 0. Subtract 1. Square root both sides. And x is plus or minus I. So there's 2 real and 2 imaginary zeros. 1, -1, I, and -I. And that concludes section 4.5.